So in this section, we're going to look at differentiating functions where the x is being replaced by ax plus b. And again, I'm just going to show you this proof using the chain rule. So here we're going to let u equal ax plus b. So therefore, du on dx. When we differentiate this, we just end up with a. That means that y is equal to sine u. And again, if we differentiate dy on du, we end up sine differentiates to cos. So we get cos u. And then bringing all this together with the chain rule. So the chain rule, as a reminder, is dy on dx is equal to du on dx times by dy on du. And if we do all that, we get du on dx is just a times by dy on dx, which is cos u. And so I'm just going to have to make some space over here. That's equal to a lots of cos u, and then just replacing that u again with what we substituted in for it, which is ax plus b. So the difference of that becomes a times cos ax plus b, which based on our previous work comes as no surprise, because that a is pretty much just the differential of this bracket here, multiplied by the differential of sine. Now if we look at this in the context of some examples, so here we've got differentiate tan of 3x plus 1. So if we want to find the derivative of this function here, right, we differentiate the bracket, and the differential of that is 3. And then we differentiate the trig function itself. Well, tan differentiates to sec squared, so with sec squared 3x plus 1. And then we can just simplify that as 3 sec squared 3x plus 1. Okay, moving on. We have to differentiate tan of pi plus x squared. Note how this is not inside the bracket, therefore we've actually got two separate terms here, and we'll differentiate these as two separate terms. So firstly, tan of pi plus x. The differential of this bracket is just 1, because the pi is a constant, so we differentiate that becomes 0, and the differential of x is just 1, so that becomes 1. Times by the differential of tan, which is sec squared, so sec squared pi plus x, plus the differential of x squared, which is 2x. And if we tidy this all up, we end up with sec squared pi plus x plus 2x. So again, we've just got two separate terms, so we differentiate them as the two individual terms that they are. Now, next one, again, we start off by differentiating this bracket here. So if we differentiate, the differential of 2x minus 1 is 2, times by, now we've got a constant out the front, that's okay, the constant stays there, but we've got to differentiate sine, and sine differentiates to cos, so therefore we end up with negative 3 lots of cos 2x minus 1, and if we simplify all that, we end up with negative 6 cos of 2x minus 1. And that finishes up our worked examples of how to differentiate some trig functions of the form ax plus b.